What happens when a landslide begins? It often starts with a sound so quiet that no one notices it. A faint crack beneath the ground, a shifting stone, or the slow movement of soil that has held its place for thousands of years. Until one moment when gravity quietly takes control, most people imagine a landslide as a sudden wall of earth crashing down a mountainside. But the truth is far more unsettling because by the time the movement becomes visible, the conditions that caused it have usually been developing for days, months, or even decades beneath the surface. A hillside may appear stable, covered with trees, roads, and homes, while deep below, invisible changes slowly weaken the ground until the landscape reaches a point where it can no longer support its own weight. A landslide is not simply falling dirt. It is the moment when gravity overcomes the strength of soil, rock, and vegetation. Every slope exists in a delicate balance between the force pulling material downhill and the forces holding that material together. These resisting forces include friction between soil particles, the roots of plants that bind the ground, and the internal strength of solid rock. When that balance changes, movement becomes inevitable. One of the most common causes is prolonged rainfall. As water seeps into the ground, it fills the tiny spaces between grains of soil. This water increases the weight of the slope while simultaneously reducing the friction that normally keeps the particles locked together. The ground slowly loses its ability to resist gravity. Eventually, a single additional drop of rain can become the final trigger. Not because it is powerful by itself, but because the slope has already reached its breaking point. Earthquakes create another pathway toward failure. Vibrations shake loose rocks, fracture solid bedrock, and rapidly reduce the stability of steep terrain. Even a brief earthquake lasting only seconds can release millions of tons of material that have remained motionless for thousands of years. Human activity can also transform stable hillsides into dangerous ones. Roads carved into mountains remove the natural support at the base of slopes. Mining leaves underground spaces that weaken the surface. Construction adds extra weight where the land was never designed to carry it. Deforestation removes tree roots that once acted as natural anchors, allowing rainwater to penetrate deeper into exposed soil. Scientists classify landslides into several types. Rockfalls involve large pieces of rock breaking free from cliffs. Debris flows behave almost like rivers made of mud, water, rocks, and broken trees, moving at astonishing speeds. Earth flows move more slowly, with entire hillsides gradually sliding downhill over months or years. Rotational slides occur when blocks of earth rotate backward as they descend along curved surfaces hidden beneath the ground. The speed of a landslide can vary dramatically. Some move only a few centimeters each year, almost impossible to notice without precise scientific instruments. Others accelerate within seconds, reaching speeds faster than a person can run. In extreme cases, massive debris avalanches can exceed 100 kilometers per hour, leaving almost no opportunity for escape. For the environment, the consequences extend far beyond the initial collapse. Forests disappear beneath layers of rock and mud. Rivers become blocked by natural dams that may suddenly fail days or weeks later, releasing catastrophic floods downstream. Lakes can form where valleys once existed, permanently reshaping entire landscapes. Wildlife suffers silently. Animals lose nesting grounds, migration routes vanish beneath unstable terrain, and fresh water